All right, hello everyone. Welcome to FE Workshop series. This is Nicholas speaking. Hope we have some fun today. We're going to be working on some mechanical problems involving fluid properties and fluid statics. This will be posted up later today, and hopefully you will find it useful for your FE studies. All right, I'm currently looking at Section 7, Fluid Properties. We're going to do problems number 1, 2, and 6. We're going to start with problem number 1 here. Okay, we have a leak from a faucet. Comes out in separate drops instead of a stream. What is the main cause of this phenomenon? So you know when you have a leak in your house in the faucet, what normally is the cause of a leak? Is it gravity? We also have air resistance. Viscosity. And surface tension. One of those multiple choice problems. Now, what do we think the answer is going to be? The correct answer is going to be surface tension. Do we know why? So surface tension is caused by molecular cohesive forces in a fluid. And this is the cause of the formation of the drops of water, because the molecular cohesion is what causes the droplets of water to stick together and form a stream. Surface tension is, in that case, being a lack of surface tension, would cause the water droplets to come separate as they're dripping out of the faucet. There is a lower surface tension when that is occurring, so instead of coming out as a stream, it will drip. So the correct answer for this is D. Nice. Okay. Let's go on to problem number 2. This is a little bit of a longer problem. We have, let me see if I can draw this out. A solid cylinder is concentric with a straight pipe. It's our cylinder, and this is our straight pipe. The cylinder is 1/2 meter long and has an outside diameter of 8 centimeters. Okay. .8 meters. No, not 0.8 meters. The cylinder is 1/2 meter. Okay, that's 1/2 meter long. Inner diameter. Outside diameter is 8 centimeters. Inside diameter is 8.5 centimeters. So this gap that we have is about 0.5 centimeters. All right. We have a specific gravity. Let's call specific gravity SG. And a kinematic viscosity of 5.57 times 10 to the negative 4. Now we want to find the force needed to move the cylinder along the pipe at a constant velocity, 1 meters per second. Okay, that is our information for this problem. Yes, we're looking for a force. So there is an equation that relates the force over area to the viscosity with a change in velocity and a change in y position. We'll write this down. There's not necessarily a specific name for this equation, but it relates force over area to dynamic viscosity times change in velocity over change in y. Y being could be the radius diameter. So with this being said, what information do we currently have? We're good on the velocity. We have the velocity, change in velocity is going to be 1 meters per second. Our change in y, we don't necessarily have that yet, so we'll have to find that. We don't have this either. We need to find this, this, and this. So then we can use this equation to find that. So let's see what we can find first. Let's go for our kinematic viscosity, convert it to our dynamic. So our dynamic viscosity is going to be equal to, I should write it this way first. Our kinematic viscosity is equal to the dynamic viscosity divided by the density. And we know what the density is going to be because we have our Sg, which is our density in regards to how it relates to the specific gravity of water. It's 0.92, the specific gravity of water. So what we can do is we can rearrange this so that mu is equal to this. So we have this is going to be 1,000 kilograms per meters cubed times 0.92. And this number we have is 5.57 times 10 to the negative 4. So with this we can get our mu is equal to 0.512 Pascal times seconds. All right, cool. We got one of our pieces of information. Now let's look and work on getting the change in y, our separation. This is going to be called delta. And what is delta? Delta is going to be our diameter of the pipe minus our diameter of the cylinder, all divided by 2. So we got that here, correct? 0.5. Now we just take this and divide it by 2. It's going to be about 0.25 centimeters. All right, second piece of information has been gotten. Last piece of information we need, according to this, that's good, that's good. We now just need our area, surface area. Our surface area for a cylinder is going to be pi dl, or 2r pi l, whichever you like. And this is going to turn into pi times 8 cm divided by 100 cm per meter to get our units converted, times 0.5 meters. 0.5. This is going to equal 0.126 meters squared. All right, now that we have all this information, let's see what we can do about this force. Let's rearrange this equation. Force is equal to A mu dV dy. This is going to be 0.126. I'll leave units out because I don't have a lot of space. We're going to multiply that by our mu, which was 0.512. Where is it? Oh, 512. Then we're going to multiply it by, I'm going to move down here, times 1 meter per second divided by 0.25 centimeters. We need to do some conversions here. Divided by one, or multiplied by 100 centimeters per meter. And what do we get in the end? We get a force resulting in 25.8 newtons, which is most closely resemblant of 26 on our answers, which is choice C. Okay, so this problem gives you a bunch of information that you need to use in conjunction with other equations to find the overall solution. This one is one of the longer problems and will definitely require you to remember some basic formulas from fluid mechanics, fluid properties. This one in particular, if you know this one, you know how to get the force. Then all you have to do is figure out how to get the other information. Awesome. Hopefully that was useful. We'll go on to the next problem now.